Hello friends, I Pankaj Dumka welcomes you on this particular lecture, and today what I'll be doing, as I have already promised with you, that in this lecture I should tell you how to solve few problems on buoyancy. So this is the one problem. This says that you have a metallic block having density rho m, and this particular block was floating at the interface of oil and water. The density of oil is rho L and the density of water is rho W. Now the question is, what is the ratio x by y for the condition which is prevailing here? Now, how to proceed the problem? Look, what are the forces acting on this block? What are the forces acting on this block? First one is the weight of block. Second one is the force which is coming onto block due to water. So buoyancy force due to water. At the same time, oil will also be pushing this upward. So because this particular block has also displaced some amount of oil. So the buoyancy force due to oil. So if you look closely, then you can write that the net vertical force is 0. So weight of block downwards will be equal to buoyancy force of water plus buoyancy force of oil. Okay. Now, what is the weight of block? Weight of block will be mass of block times g. What is the buoyancy force due to water? That will be the weight of volume displaced. So how much volume has been displaced? Let us say that the cross sectional area of this block is A. Okay, then the volume displaced will be A times Y by water, of water, and this is the volume. When it is multiplied by density of water and G, it becomes the force, weight of that particular. So it is density of water times G plus oil buoyancy force. So that is the weight of oil which has been displaced by this particular block. So it is rho of oil. Let us say this is oil. Okay, so rho of oil times G times volume displaced, which is A times X. Okay. Now, what is mass of block? That is density of block times volume. So volume is A times X plus Y. G will be equal to A Y rho W G plus rho naught G A X. So this A will be getting cancelled out along with G. So you are left with rho of block X plus Y, rho of water Y, rho of oil X. Okay, so what is required? X by Y is required. So you divide the whole equation by Y. So this becomes X by Y plus 1 rho W plus rho naught X by Y. Okay, so you segregate X by Y onto one side. So this is X by Y. This is rho of block minus rho of oil. Okay, and this will be rho of water minus rho of block. So what is X by Y? This will be rho of water minus rho of block by rho of block minus rho of oil. So in this way you can tell that what is the relative proportion. Now this is very similar to saying, okay, you all know Titanic sank, okay, so why it sank? So let me explain this with the help of an example. Now assume that this is Titanic. Okay, so this is the one, and this is floating on water. Okay, now this was the iceberg. which was floating, and from which the Titanic got collided, okay, and ultimately sank. So what was the problem? Problem was the person who was watching, he was not aware that how much the block was, how much the iceberg was inside the sea. So let us do this analysis. Let us say that the total volume of iceberg is V, okay, and out of that, this much volume was visible to the person, okay. So let us say this is above A, okay, and this is below. So this much volume is below. Now if you try to assume again that the density of water in the sea is let us say 10, okay, 110 kilogram per meter cube because of the salt content there. And as this is iceberg, so this will be lighter. So let us assume that this is having a density of 990 kg per meter cube. Now comes the analysis. Look, the weight of this iceberg should be balanced by what? Should be balanced by the buoyancy force. So what is the weight of this iceberg? That will be the density of this iceberg, that is rho I, times the volume of this iceberg, that is V, times G. Okay, and what is the buoyancy force? That will be weight of volume displaced. So how much volume has been displaced? It is V beneath VB times G times density of water. So they should be equal. So rho I Vg is equal to rho W VBG. So you can cancel this and you are left with, so how much volume is there? That is rho I by rho W. Okay, so what is rho I iceberg? That is 990, and what is rho W? That was 1010. So how much volume was visible above? So that is V above will be total volume minus volume below. Okay, so this is total volume minus 990 by 1010 times V. So VA will be V times 1 minus 990 by 1010. Okay, so VA will be, let me solve this. So this will be 1 minus 990 divided by 1010. So that is coming out to be 0.0198 V. Now you can see this is a very small amount. Okay, so if you want to see the percentage, so this is only 1.98%. So rest will be beneath the sea level. Okay, so 98% will be below the water level. So that's why the person who watched the bird thought that they will be able to they will be able to move by side of this, but that doesn't happen because of huge amount of bird beneath. Okay, so this can be one of the problem. And let me solve one more problem for you. This problem says that you have, let us say, a cylinder. Okay, this cylinder is in such a situation that this cylinder is having diameter D. Okay, and half of the cylinder is in oil of density rho O and half is in water. So if this total length of the cylinder is L, so this will be L by 2. Okay, now from top you have a string. which is holding this, and this cylinder is having, let us say, a density of rho cylinder. So the question is, what is the tension in this string? So if you look for equilibrium of this, so this rope, this block will be pulled by rope, and at the same time this is pulled. So if you cut it from here, so what are the forces? So W, weight of cylinder, buoyancy force due to water, and buoyancy force due to oil. So if you balance everything, then you should get, let us say this is tension in the rope, so T upwards plus buoyancy force due to oil plus buoyancy force due to water, that will be balancing W. So this T will be W of this cylinder minus buoyancy force oil minus buoyancy force water. So this T will be, what is the weight of cylinder? That will be density of cylinder times G times the volume of cylinder, which is, let us say that the area is it is pi by 4 d square, so we won't be keeping. So if you want to keep, then you can do it. Let us keep, but that will make the expression bulky, but that doesn't matter. So it is pi by 4 d square times L, okay, minus buoyancy force due to oil first. So the volume of oil displaced is, it is pi by 4 d square times L by 2 is the volume of oil displaced, and times rho of oil G minus pi by 4 d square L by 2 rho of water G. Okay, now this T, then you can take this pi by 4 d square G and L as common. So pi by 4 d square G and L, so it is rho C. Pi by 4 d square G and L, that is rho naught by 2, and that is rho W by 2. Therefore the tension acting will be what? That will be pi by 8 d square G L into 2 rho C minus rho naught plus rho of water. So this is the tension which is coming onto this string. So friends, in this lecture till this point only, what I'll do in the next lecture, I will be solving for the stability of basically first the submerged body, fully immersed case, and then we'll be talking of in the next lecture we will be talking of stability of floating bodies. So thank you very much. If you liked my video, then please do like, share and subscribe. Take care.